Alright, ladies and gents, this is the third method that we are using to solve a system of linear equations. And the third method is called elimination. So as you can see, this is day 1 of 2, and this is the basic way, the blueprint of how to use elimination, how to recognize certain systems that you can use elimination right away in order to figure out if there's an intersecting point between the two lines. So the first example, solve the linear system using elimination. You want to focus on the two equations, and I always like to number them 1 and 2 first, so that's what I'm going to do first. And when you use elimination, you want to make sure that everything is lined up. By lined up, I mean you're looking for if your x's all line up nicely, your y's all line up nicely, and then the numbers or the constants all line up nicely as well. So in this case, our first equation is 3x minus y equals 5, and the second equation is x plus y equals 3. Since all the terms are lined up nicely, I'm going to go ahead and see if I can use elimination to solve the system. So when you use elimination, you're looking to see if you can cancel out any terms if you added the two equations right away. So if I look at my x's, right here, 3x plus x, if I use addition, I'm always going to use addition, that's what I would like to use. 3x plus x does not cancel out, it would actually end up being 4x. My next term, I have a negative y plus y. Well, negative y plus y actually cancels out. So then right away, I can combine the two equations using addition to make one equation. So when I do that, I get 4x plus 0y equals 8. That's what happens when I combine both equations using addition, knowing that I can cancel out one variable, one term right away. I do not want to combine equations until I know for a fact that I have canceled out a variable. So then working with my new equation, 4x plus 0y equals 8, I know that anything times 0 ends up being 0, so that cancels out right away. So I'm just left with 4x equals 8. So then solving for my x, I divide both sides by 4, and I get x equals 2. Now I have one of my variables, x. Now to check to see what my other variable is going to be, y, I'm going to go over here, and I'm going to use the second equation just because I picked it, and I'm going to substitute in my value of x. So if you look at my first equation, look at the equation I've written down, I have x plus y equals 3, and then I put in the 2 because I figured out what it was in that equation earlier. So then if I simplify further, if I subtract 2 from both sides, y equals 1. So just to double check to see if my answers are right, I'm going to use the second equation again and substitute what I know. X is 2, y is 1. Does that equal 3? 3 in fact equals 3. Checked, it's good to go. So that means we have an intersecting point between these two equations of lines, at 2, 1. Alright, the second example is a little bit more difficult than the first that we just went over because everything was all lined up nicely and all I had to do was add the equations together to get my third. This time, if you look at the equations in our system, we have 3x plus 5y equals negative 2, and we have 2x minus y equals 3. So before I do anything, I'm going to label my equations, 1 and 2. And then if you look at each term in each equation, if I added 3x and 2x, that's not going to cancel out my x variable. If I added 5y and negative y, that's not going to cancel my y's, and we don't really care about the constants. We just want to make sure that when we use elimination, before we combine any of our equations, we have to cancel out one of our values of y or x. Okay, so then the method of using elimination is that we have to manipulate one of the equations. So before I even combine any of the equations, I'm going to create my system again and rewrite both equations in there. 3x plus 5y equals negative 2, check, and then 2x minus y equals 3. Alright, so looking at both equations, the one in blue looks like it's going to be easiest to work with. Okay, so if we line it up with the 5y, you have to think in your brain, what can I multiply the second equation by in order to cancel out my y's? Well, 5y positive, I have a negative y. So I think I'm going to multiply the second equation by a 5. So when I multiply my second equation, keeping my first equation, my system the same, I get 10x minus 5y equals 15. Do you guys see how I did that? If I multiply it out, let's use green here. Seems a standout color. You have 5 times 2, which is 10x, 5 times negative 1, which is negative 5, and then 5 times 3, we get 15. That's how we get every single term in that second equation. So then that being said, after I manipulate the second equation or one of the equations so I can cancel out my terms, I'm going to add the two equations together. And you only use addition when you're trying to cancel out one of the terms. So if I add those two together, let's see what we got. We get 13x. Our y's are gone because we have a 0y equals 13. So if I continue to simplify my equation, 13x equals 13. If I divide both sides by 13, x equals 1. So we have one of our variables, and to see if that's right, I'm going to find out what my y is by using one of the equations. I select the second one for some reason. And I'm going to substitute in 1 in for x, simplify. So I get negative 1 equals y. I'm sorry, negative y equals 1. I'm not done. I need y all by itself, not negative y, but a positive y. So I'm going to divide both sides by negative 1. So then my answer is negative 1. X is 1, y is negative 1. Just to double check, I'm going to substitute my values that I found for x and y into one of the equations. Still working with number 2. That's fine. So 2 times 1 minus negative 1 equals 3. We're checking to see if the left side of the equal sign is equal to 3. 2 plus 1 equals 3. Well, 3 actually equals 3. It checks out. So then, as an ordered pair, I have my x to be 1 and my y to be negative 1. The two lines intersect at 1, negative 1. Okay? And just to let you know, the secret word is cookie. So write down cookie at the top of your paper, just so that I know that you've actually watched the video, and don't tell anybody, it's a secret. Good job. Make sure you guys watch the video, take notes, ask questions, and then the next day we're going to go over any questions that you have, and make sure you are focused and practicing, because we have now a third method in solving our linear systems. Okay? Also write down the word dragon. So you should have cookie dragon.